Hey everyone, what is happening? I hope you all had a good long weekend. We are getting into the last little bit of our nervous system unit, and we're going to be talking about the autonomic nervous system today. And what we have here is we have the whole nervous system. We've got our central nervous system, which is the brain and the spinal cord. And then we have our peripheral nervous system. This is everything outside the spinal cord and brain. And we've done our sensory neurons, and that had to do with our reflexes. And then we've got our motor neurons, okay? And they're broken up into two different categories. We've got somatic nervous system, which somatic means body, all right? So this is voluntary movements. So this is you thinking about where you are in space, and like say for swimming, for example, you're thinking about a high elbow. Now eventually this moves into a possible, a pattern that you don't even have to think anymore about having that perfect stroke, all right, for that example. Now, today what we're going to do is we're going to talk about the autonomic nervous system, and these are involuntary movements, all right? So these are all the things that we don't have to think about, which is absolutely fantastic, because if we did have to think about, say, things like breathing or heart rate, we would not be able to do anything else because we'd just literally be worried about staying alive, all right? And so this autonomic nervous system is broken up into two different parts, and we've got our parasympathetic nervous system and our sympathetic nervous system. Okay, now what you'll notice from this picture is that they innervate the same things. All right, that's really key, but they have different effects on these different organs or areas of the body. All right, and so here's a quick little comparison. So our parasympathetic, and I really want you to remember this part, is it's rest and digest. All right, so this controls all our functions at rest. It maintains homeostasis, which is balance in our body. It causes muscles to relax. It decreases our heart rate, decreases our blood pressure, and it also increases blood to our digestive system. All right, so this is our parasympathetic, rest and digest. Now, on the flip side of our autonomic nervous system, we have the sympathetic nervous system. And how do I remember that? Well, S and stress, well, sympathetic and stress both start with S, all right? And this is our fight or flight. You've probably heard of this before. Now, the sympathetic nervous system prepares our body to react to a threat. It causes muscles to contract more forcefully. It increases our heart rate. It increases our cardiac output. It also diverts blood away from our digestive system, and more to our and makes it go to our muscles. All right, it increases our breathing rate, and it also increases our ability to make ATPs to fuel those muscles working. All right, and so we've got a few more pictures here, and you can see that our parasympathetic nervous system is over here and our sympathetic nervous system is over here. They innervate the same things, but they have different purposes. All right, so what are the physical differences of the parasympathetic and sympathetic nervous systems? Okay, so we're going to start with our parasympathetic nervous system again. And so what we have is we have at the very top of our spinal cord, we have the cranial nerves. And so you can see here that the parasympathetic nervous system is innervated by nerves at the top of our spinal cord and at the bottom of our spinal cord. Whereas with the sympathetic nervous system, they're innervated from the middle of our spinal cord. Okay, so that's one big main difference. Okay, now you'll also notice that there's long preganglionic nerves in our parasympathetic nervous system and short postganglionic nerves in our parasympathetic nervous system. And this is different from our sympathetic when we see really short preganglionic. So those are from our spinal cord, and then we've got really long postganglionic nerves. Okay, so if we go up here, we just see that our parasympathetic nervous system is coming from the top of our spinal cord and from the bottom of our spinal cord. Okay, whereas the sympathetic nervous system is coming from the middle of our spinal cord. Okay, now the first nerve coming off the spinal cord, they are long for parasympathetic, and then that motor neuron is really short, that second nerve. Whereas with our sympathetic nervous system, the initial nerves are very short, and then we have long postsynaptic neurons. or postganglionic neurons. Okay, and so you can check out what they all integrate here. I'm just going to zoom in a little bit, and we can check that out. All right. So what I really think is cool is that if we just take this for example for our stomach, the parasympathetic nervous system stimulates digestion, and that's via the vagus nerve. And then if you look at what the sympathetic nervous system does to our stomach, it actually inhibits digestion. Okay, and so that it can send all that that blood to the muscles, the working muscles, to get away. All right, and so one more thing, and this is really interesting. This takes us back to our synaptic cleft lesson. So there's only, for our parasympathetic nervous system, there's only one neurotransmitter substance being used. This is acetylcholine. All right, and so it's used in the preganglionic nerve and in the postganglionic nerve. Okay, for our sympathetic nervous system, acetylcholine, the neurotransmitter substance, is used in that first that junction, and then the second junction, the neurotransmitter substance secreted by that axon terminal, is norepinephrine, which is another word for adrenaline. All right, so that's another big difference. Remember that this one, the parasympathetic nervous system, is calming, and the sympathetic nervous system is exciting. Okay, now going a little more in depth into our sympathetic nervous system response, there's actually two ways that this can be initiated. All right, and there's like a really short, fast way to get like us going to get out of there, and then there's one that sustains us over a long period of time, and if there's too much stress for a long period of time, it's actually detrimental to our health. All right, so what I have here is I have an eyeball, and what they see is they see a gun. Oh no, oh my God. That information comes in from the eyeball, and it goes into the thalamus where it gets sorted, and it goes through the amygdala as well, which is like, oh no, we're threatened, we're feared. The amygdala talks to the hypothalamus, okay, and remember from reproduction, the hypothalamus is involved with a whole bunch of different hormones. Okay, so from the hypothalamus then, that impulse is sent through two ways. Okay, we get a hormonal response, and we have a nerves response, a neurotransmitter response. Okay, so we're going to focus on the first one. The hypothalamus sends out acetylcholine along its nerves, and then it goes to the gets to norepinephrine, and that hits the adrenal medulla on that hits the adrenal medulla on the top of our kidneys. So you can see that's the inside of our adrenal gland. All right, and so what happens is the adrenal medulla sends out epinephrine, which increases alertness, increases ATP production, and it increases our heart rate and muscle contractility. Okay, and this is very, very fast. So we have a neurotransmitter substance side to this, and we also have a hormonal response that takes a lot longer. Okay, and so the hypothalamus is going to secrete corticotropin releasing hormone, and that targets the anterior pituitary, and then the anterior pituitary releases adrenocorticotropic hormone, and that targets the adrenal cortex, all right, which is the outside of the adrenal gland, and then the outside of the adrenal gland secretes cortisol, and you've probably heard of cortisol before. This is a stress hormone, and what it does to the whole body is it increases blood pressure, it increases glucose release, but unfortunately, prolonged exposure to cortisol is going to decrease the immune system response. All right, and so these are two things, and I'm just going to make my screen smaller here so you can see the whole thing together. Okay, and so we have that information come in from the eyeball, goes to the thalamus, the amygdala sorts it, it's threatening, and it hits the hypothalamus. The hypothalamus does two things. One, it releases acetylcholine, and that goes along the nerves, and it's released into our neurotransmitter substance, and then we get norepinephrine released, and that targets the adrenal gland, more particularly the medulla. The medulla secretes epinephrine, which is another name for adrenaline. Okay, so we get that shot of adrenaline. And then what we have is on the right-hand side there, the hormonal response. We've got a corticotropin releasing hormone, targets the anterior pituitary. That releases adrenocorticotropic hormone, which targets the adrenal cortex. And then what we get is we have a stress hormone called cortisol, and that increases blood pressure and glucose release. But unfortunately, it decreases our immune system response. And this is why people in like really, really stressful jobs or really, really stressful living situations for a prolonged period of time, that's why their health decreases even more so than, say, someone not in that situation, is because they're always stressed out. They've got more and more or elevated cortisol levels, and that really suppresses their immune system. So they get sick more often, and they're going to be more susceptible to possibly missing work or catching something that they don't really want to catch. All right. I've also got another diagram here that you can check out. And this is just talking about the dual response of the sympathetic nervous system as well. All right. So we have our autonomic nervous system right here. We've got our parasympathetic nervous system, which is rest and digest. And then over here, we've got our sympathetic nervous system, which is activated in situations needing energy and arousal. Okay, so we go to the adrenal medulla. Adrenaline and noradrenaline arouses sympathetic ganglia, and this is really short-lived. It increases alertness, increases blood flow to the muscles, increases heart rate, respiration rate, and it reduces activity of the digestive system. All right. Now we also have over here, we have a slow response to stress, and this is through the endocrine system that I just talked about. And those are the different hormones that get released to the anterior pituitary. They go and they target the adrenal cortex. And then what happens is this maintains a steady supply of glucose for energy. It suppresses the immune system, okay? And then this is what really makes the long-term damage. And then both of these systems prepare for fight or flight response, okay? So check that out, and please ask me any questions. I'm more than happy to help. All right, talk to you soon.